Welcome everybody to the OpenUSD Insiders live stream. I'm so excited. I do not want to hold off on showing these great, beautiful faces here with us. As you can see, we have a dream team actually on this live stream. We're going to be talking about scaling imitation learning with synthetic motion data using Groot Mimic. We have none other than the amazing Lychee AI himself, Muammar Bey. Welcome, Muammar. It's so good to have you again. This is your appearance number 3, right?
Yeah, exactly. Thank you so much for having me. I'm very excited for today.
We are psyched, and also very psyched that you're now consulting with an amazing a partner and customer of NVIDIA Omniverse, the FS Studio team. We have Bobby Carlton here, the global biz dev guy for FS Studio. Hey, Bobby.
Hey, hi everyone.
And we also have the CEO hanging out in the background in the wings. He's traveling right now, so he might jump in at different points. But Tim Martin is also here joining us. Hey, Tim.
Hey guys, apologize for the spotty audio, but yeah, it's great to be here.
That's great. We're honored. It's fantastic to have you here. And of course, we have the amazing regular live stream viewer, amazing robotics developer, Kamati Richards. Thank you so much for joining us from Amazon Robotics team.
Oh, wow. Thank you. I'm happy to be here and look forward from AWS. We're going to have a few interesting announcements regarding Isaac Sim and Isaac Labs and LibRobot.
I can't wait. Yeah, we're going to go through a lot of stuff on the stream, so it's going to be action packed. From our side, we have the amazing Gus joining us. Hello, Gus.
Hello. Hi. I'm back again.
You're looking great. Well, we were talking about this in the warm up. Your mustache looks fantastic.
What's the point of having a ton of facial hair if you don't get to have fun with it once in a while, right?
I'm jealous. I'll have the only way I can do it is if I buy a fake one, and it would not look as good as yours. So,
well, thank you.
Speaking of facial hair, we've also got Strangeflow with us.
Hey, everybody. I don't have that good of a mustache either. I'm sorry. Best wins the mustache award. You know.
Looks great. So we're going to have a lot of fun, as you can tell, over the next hour. Before we begin, let's go over some quick things, which we're super excited about as well. Of course, SIGGRAPH is coming up. Many people from video will be there. I'll be there with my great colleague, Amelia, who's actually producing the live stream as usual and hanging out in the chat. So feel free to say hi to Amelia there. So both of us will be there. And if you are going, we'd love for you to connect with us. We've actually set up a WhatsApp group for anyone who's going to be on site. That's where we'll be able to tell you about the different sessions happening related to NVIDIA Omniverse and robotics. If you need help meeting with somebody, there's some great mixers happening, actually. There's OpenUSD Day. There's an OpenUSD meetup happening. It's going to be a great week in Vancouver. So if you have the ability to come, highly encourage you to come and also let us know, like I said. We also have a discount code, which I think gives you a free Expo Pass. And that Expo Pass gives a lot more than access to the Expo. There's a whole list of things you can get with that free Expo Pass. So if you're on the fence and you're able to make it, maybe that'll help push you over the edge. I hope you do come. It's going to be a lot of fun. That QR code will give you the NVIDIA page going over pretty much everything, including these sessions from some very special people at NVIDIA. These sessions are going to be broadcast live to everybody around the world. So you do not have to be attending SIGGRAPH in person to experience these sessions. That QR code will tell you more about that content, but that's going to be on Monday, August 11th. The OpenUSD, as I mentioned at SIGGRAPH, is going to be a full day full of sessions. And I believe the next day after that, we have that OpenUSD meetup, but that QR code will give you more details on the OpenUSD day. And then, like I said, this QR code will bring you right to that WhatsApp app group that Amelia set up a couple weeks ago. We've already got some great people there interacting, letting us know about what their plans are for SIGGRAPH. And of course, these are our normal links we have. So if you want to find out what's coming up in terms of office hours, in terms of live streams, in terms of study groups, in terms of keynotes and things like that, go to that events page. That's our Ed event page where you can subscribe or just check out what's coming up in the coming days. That link will bring you to our official support forum, our Discord server, and then that last one is for our community page where you can look up about our different ambassadors who I hope one or more will actually be at SIGGRAPH with us. Okay, so we have a full hour, so I wanted to really get started of running. Let's do some proper introductions from everyone who's joining us now. Okay, so we did some quick ones earlier, but Gus, why don't you? Your name is actually Michael, but everyone tells you Gus.
Yeah, there are a lot of Michaels in my life, so I go by Gus. Full name is Gussert. I'm a research scientist and engineer. I've been a part of Isaac Sim since the beginning, and I'm just here. I'm hoping to to answer questions however I can and contribute however I can. And introduction, I don't know what to say.
That's great. That's perfect. No, you're always super helpful on these types of live streams. So great to have your mind with us today.
Glad to be here.
Another great mind here. I'm always thankful for my partner here, Eric Strain, aka Strainflow. Eric, why don't you tell me about your role here at NVIDIA?
Yeah, I'm a technical marketing engineer, and my role is to help as many people as I can adopt NVIDIA robotics.
And you'll see Eric often with his moniker Strainflow on the Discord server, and obviously a big part of these chats. Speaking of which, I want to give a big thank you to Shane Reitz, who hosted last week, an amazing live stream. We'll put that with Vention. We'll put the link up in the chat. Really compelling. I watched it the whole time. I was on vacation. I still watched it because it was awesome. So thank you, Shane, for that. Okay, and now we have from FS Studio, Bobby Carlton. So tell everybody a little bit about your role at FS Studio, and then I got a great video we'll play actually, showing off a nice sizzle reel of some of the work you've done with some of your great clients.
Yeah, sure. So I'm Bobby Carlton from FS Studio. I reside in upstate New York, and I am the head of business development for digital solutions for the studio. I've been with the studio for, I want to say since 2022. I spent many years working at Apple. I did a lot of consulting work with like Disney and Google and Nike, doing a lot of sort of a digital solutions adoption. I am not a dev, but I am a true like inspired nerd. The 1982 movie Tron sort of launched me into this world of digital solutions, and being a guy, in 2025 working with robotics and simulation is just a massive dream. But that's me in a nutshell.
Well, you say you're not a dev, but I learned so much from your posts on LinkedIn. I'm putting Bobby's LinkedIn page on the YouTube chat right now. So I highly recommend, if you're into this type of content, if you're into robotics, you're into what companies are working on next, I highly recommend you follow FS Studio, but specifically also follow Bobby Carlton's own page. Bob, you also write a great weekly newsletter. It usually comes out on Fridays. I love going through that. Really, really insightful. So we're honored to have you here. Before I play your video, let's finish with the introduction. Kamate is here from Amazon robotic team. So amazing to have you here, Kamate. Another amazing person to follow. I'll put his link on LinkedIn as well. You've got some exciting things in the works. Do you want to tell us a little bit about that?
Yeah, absolutely. Well, first of all, not only do I work with Amazon Web Services, Robotics, and I lead our community teams for embodied AI, I also volunteer my time with Hugging Face Le Robot, and I've worked quite closely with Rob Knight. I consider him a friend of mine, the creator of the SO100 101 arms and the Hope Jr. So if you saw the $3,000 robot,
oh my gosh, it's amazing.
Yes, Remy Cadence and team, I had a bit to do with that development and simulation using Isaac Sim. So there's a lot of stuff in the works. What we're doing specifically at AWS is we're trying to figure out how to scale distributed training and distributed learning. So that is quite a challenging task. And we're created a few blogs on how to get started doing that using the Lay robot. So it just extends what you already have from Lay robot. If you have an SO100 or 101 arm, you can get started here. And if you don't have one, you need a GPU, and you can use Isaac Sim and Isaac Lab to get started. So working on a bunch of things. And I think the last thing I'll say is working on a get started tutorial using some college students that are very well versed in Isaac Sim. They've created robots using Isaac Sim and Lay robot. And you'll get to start from zero and end up doing two-handed operations with Isaac and Groot. So there's a lot of stuff going on. Just look forward to my LinkedIn page, and it'll be showing everything that's coming out over the next few weeks.
Amazing! I'm so impressed. I'm so glad we got to meet a chance to meet recently. You also, I'm so grateful you introduced me to Rob Knight. So we're also going to plan a live stream specifically with Rob and Kamate. We're going to go over his work that he's mentioned. Obviously, we're going to cover the SO arm today, actually, which is also great. Okay, but last but not least, we have Muammar Bey, who's here now, a consultant for FS Studio, which is amazing. As everybody who's familiar with these live streams know, Mormar is just a powerhouse in the community, producing some amazing tutorials on a regular basis. Very engaged on the Discord server. He's got his own Discord server now. He also has a tournament that's still in progress that we just announced, I think, yesterday, that NVIDIA has contributed some Brev credits, including some cash prizes that Muramar's put up. So tell us all about it, Muramar. It's so great to have you here.
Yeah, sure. Hi, my name is Mohamed, like you mentioned. I also go by Litchi, as I have this YouTube channel Litchi AI. And I mean, I think you already introduced me quite well. I'm just very happy to be here for FS Studio. And yeah, I'm happy to show the Groot Mimic pipeline.
Yes,
and,
okay.
On the SOARM 101.
This is going to be really fantastic. Okay, so I think we got plenty of time. So I'm going to show a quick video before we get into the topic of today. I want to show a quick video of some of the amazing work that FS Studio has done, which helps bring Muramar here today, and Bobby. So let's watch this great video, and then we will get into the topic at hand. I want to thank Bobby for providing this a little earlier. I believe this one. Let me see. This one has one. This is one music. Here we go. Absolutely amazing work. I love that reel every time. I get goosebumps watching it. So many cool things. I think we might have lost Bobby for a second.
I'm back.
Here
I'm here.
Bobby. Okay, so I want to ask you two things. One, obviously, FS Studio, your updates are like crazy. It seems like every week you guys are posting amazing work that you're doing and sharing knowledge. You're leveraging lots of great platforms, including NVIDIA Omniverse, the Unreal Engine. You're leaning heavily into robotics. Tell us a little bit about what your focus is in at FS Studio, what kind of clients you work for, and what brought Muramar over to you guys.
Sure. So right now, obviously, the focus has been a big focus around robotic simulation, synthetic data, digital twinning work, really sort of automation, across multiple industries. And I've been very lucky, as I said, I come from that foundation of total nerd. So the idea of like these tools like Omniverse, Isaac Sim, Unity, Unreal Engine, all of these things coming together, it really helped us working with companies like, Waymo, Toyota, Google, DeepMind, KPMG, MasterCard, Blue Origin. So it's a huge list of really awesome clients. John Deere, we worked with in the past, and it goes from either working on the robotic side of things, and you'll be surprised. And just FYI, you will be surprised at what companies are very interested in robotics and robotic simulation. Companies you would never even imagine or thinking about. There are a couple companies I even mentioned in that list that you're like, wait, what? They're involved in robotics, and yes, they are. And so it's really the idea of like autonomous systems and intelligent infrastructure, and all of that work has been really awesome. The current projects we have, projects that we've been having going on for a really long time. And Muramar came along when we knew about his basically his content and just how brilliant he was and how great he was on camera. We just liked a lot of things about him and the kind of content he was delivering, and especially his works in like robotic behavior and all that. And for us, it was important that we have a great simulation team, we have a great robotics team, but we needed someone like Mormar to kind of come in and sort of almost become a face for us in this sort of dev world. Again, I always joke around, I'm not a dev. I do have some knowledge of it, but if you were to corner me and start like pressing me for dev information, I would cave and be like, oh, I can't help you. But we need a guy like Mormar to help with that. So it's been a great journey, and having him on the team has just been spectacular. And I know with FS Studio, we're always looking at the client base we have, we're always looking to add more projects to our table. Again, we have a great team, and we can absolutely help you with your simulation needs or your synthetic data, your robotic needs, and especially again looking based off of what Mormar is going to be talking about today. We can dive into much deeper conversations outside of a live stream to show how we can help you.
Oh, that's awesome. Well, I'm so glad. And I listed all the companies on your website a minute ago that you guys work with. It's really impressive. I think, it's really cool when we dive into these live streams looking at these specific workflows, but it's also very cool to see the end result and the work that companies like FS Studio does with clients, kind of putting all this stuff together. So it's amazing. So I hope people who are interested in watching this, if you need some help, FS Studio is a great resource. Highly recommend you.
I think one thing to highlight here is the fact that one thing that you said that was really interesting, I think, was the idea that there's robotic automation is coming into parts of the industry that we didn't even expect. And the ability to unlock these new possible avenues of automation, that comes from data, that comes from the simulation and our ability to simulate those problems, to see what's going to happen and then find elegant solutions to them. So I'm very interested in FS Studio and the work they're doing, for sure. Yeah.
Very cool. And so thinking of elegant solutions, we have a great workflow that Mormar is going to walk us through today. As I mentioned, the topic is scaling imitation learning with synthetic motion data using Groot Mimic. Let's spend a couple minutes just to give some people some overall perspective and context here, because we're going to dive into the SO ARM 101, I believe, which is the latest version. So most people probably are familiar with that, but if they're not, let's describe that a little bit. So that's a 3D printed ARM project, right? That most people can print at home, or you can order a kit that has everything pre-assembled for you and made. But it has taken the world by storm because it really lowers the barrier to entry for working with robotics. And so that's why you're seeing so many great projects shared on different dev platforms and social media platforms like LinkedIn of people doing some really cool stuff. And it's particularly Mormar, who's really dived in head first. But we're also talking about Groot Mimic. So how would you describe Groot Mimic? Because this is probably something new to some robotics devs. So we'll start, maybe Gus, maybe you're the best person to give an overall definition, or Eric.
So I want to preface this with, I haven't personally used Groot Mimic in my research very often. My understanding of the Groot Mimic pipeline is that we can take a pre-existing model for robotic control and using intelligent data collection. So by collecting a few demonstrations that show the kind of behavior that we want, we can use the Groot Mimic pipeline to fine-tune that pre-trained model into giving us the behavior that we need to accomplish whatever automation task we've made that sample data for. But again, I haven't used it myself. I'm much more of a math.
Do you mind if I add just a little bit to that?
Please do, please, yes.
So if you have a computer vision model, what you do is you take your data set, these pictures, and you'll flip them, and you'll crop them, and you'll change their saturation and hue, and that's called data augmentation.
Yes.
And that's how you take a small data set, and through deterministic methods, you turn it into a larger data set.
Yeah.
And Groot Mimic is kind of a core augmentation for robotic trajectories. And so what you do is you would demonstrate with a robotic arm some trajectory and record it. And then Groot Mimic, using deterministic methods, is not using like a policy in itself, but it will, to my knowledge, there's probably there's almost always some policy in there somewhere, but it'll like take that trajectory. Like let's say that the arm reaches around to the right and then grabs an apple and picks it up. It will flip that and make it reach around to the left and pick that apple up. Now it's not as simple as an image, flipping an image. It's more complex, but in essence, that's what Groot Mimic does. Is it'll take a single trajectory, it'll flip it, it'll scale it, and it'll give you a whole bunch more kind of sample trajectories based off that original one. It's really cool.
Yeah.
Very cool. All right, that's fantastic. Murmur is agreeing here. Murmur, do you want to add anything to that based on your use of Groot Mimic so far?
Yeah, I think it was quite well described. So, I mean, just to put it maybe very short, just some human demonstrations are enough to create basically infinite amount of synthetic data, which then can be used to fine-tune models like Groot and 1.5. And this whole Isaac Groot project, these robot foundation models, they kind of work all together, also including Cosmos. And it's kind of like a three-way pipeline. Now, I think you just showed it on stream, and the first one is Groot Mimic. So I'm happy to show that today.
Amazing. Okay, let's do it. And I think obviously the name of the game is leveraging synthetic data to speed up robot training. So this is going to be really fantastic. I want to welcome everybody in the chat. I see a lot of great comments already. So feel free to keep adding your comments. Let us know where you're watching from. If you work on any kind of robotics project, love to hear those. Okay, so Mormon, let me know when you're ready for me to share your screen.
Yeah, I'm ready. I guess I need to allow sharing first. Okay, 1 second.
Let me see. I see your second PC.
Yeah, I'm sorry. I think now this should be good.
Okay, I got it.
Okay, nice. So yeah, you can see my screen. So
Yes.
I stole these slides kind of from the last live stream. I will also reference it later. Sorry for the bad quality, but that's kind of Groot Mimic what we just described, and this is the workflow. So we will start by teleoperating the real robot in order to create the synthetic motion in Isaac Lab. So afterwards, Isaac Lab will basically generate these novel data sets, which are also randomized, like Eric just described. And the next steps would be to use Isaac Sim and Cosmos, like leveraging Replicator and Cosmos Writer, I believe, to create highly realistic data to later then feed it into the Groot and 1.5 model. So to start, I kind of made a series at this point. So my first live stream was about how to import the robot into Isaac Sim. So I also added a little clip here. So this was the first one showing the URDF importer. So this is the SOARM 100. I have a newer version which looks a bit different, but it's kind of like exactly the same. And
you can see Gus's beard in that shot. I'm so glad I'm wearing a different shirt today. I almost wore that shirt.
I'm sorry, guys. But I'll show also the second one is kind of relevant, so I don't like duplicate myself, I guess. So in the second live stream, I was showing a ROS2 workflow, teleoperating this exact robot, and here, we could see that I was moving the robot in real, which I also have right now here, and it was teleoperated by a leader arm. So the SOARM 101 comes with a follower and leader arm, depending on the kit. And basically,
I still can't get over how quickly you went from end to end to get that working.
Yeah. It took quite some time.
Oh yeah. Okay, sorry. I don't mean to. I wasn't. Yes, it took quite some time. Yes, but I'm still. It's
still impressed.
I mean, compared to what it would. Like compared
is
to the way
saying
it
it-
used to be before Isaac Sim and Isaac Lab and stuff, like it's blowing me away.
Oh.
Oh, that. Well, I think also, Gus, is just the number of days it took him to get that far blows me away.
Yeah.
But I think what Lychee might be saying is, yeah, I didn't sleep very much.
Yeah, it took a minimum of like 2 to 3 weeks. So that's quite some days. But yeah, so I guess I will kind of share the steps I take and show it in like real time, what I did. And if I kind of fail, I still have backup. So I hope everything goes good, but just in case. So in the second live stream, I shared how to control it via ROS2. Back then, I was using joint states, but this time I will be using TF2. So I will not go into detail into this one, but for those who are familiar with ROS2, they will probably know TF2. So I first have to give some rights to read the joints and the positions, everything from the servos. I hope everything's good. And then I'm launching the SOARM TF2 script that I wrote to have this data flow. And don't get confused by the little robot library here. That was something I used in the second live stream, but technically it's not needed. And also this repository is the same from the last live stream, so I also open sourced it for those who want to try out. I hope I'm not speaking too fast. I try to explain everything by going over it quickly enough.
Perfect.
So just to visualize it quick, I'm using Arvis. So in Arvis, I just need to do 2 quick settings. So we will not see the robot model because I didn't include the URDF. But what we see right now are all the actuator positions that are read from the URDF. And like the only important part here is that we are understanding where the end effector position is by this chain, basically. And
so to be clear, the different lines here, those are the frames of each joint in the robot, right?
Exactly, yeah. Thank you. That's correct. And yeah, right now I'm moving the robot. Mm-hmm. And the only thing that I kind of included is that I attached a static frame for the end effector, which we will also see in Isaac Lab in a second. Now I will come to the Isaac Lab Groot Mimic pipeline. There was also a third stream from the NVIDIA team where they went over all the specifications, and I probably watched the live stream 2 times and went over the documentations like multiple times to really understand it. And I think this live stream explained it the best, kind of. So I couldn't really replicate it also in terms of time right now. But yeah, I highly recommend checking that out for more details. So next up, I will create a new terminal going into my Groot Mimic repository. This one is a external project in Isaac Lab. While I'm putting in some comments, maybe because if you are comfortable explaining quickly what an external project means.
An external, like an extension to Isaac Lab or Isaac Sim? Sure. So we have Isaac Lab and Isaac Sim are 2 principal tools that we're mostly using in this case. Both of them have ways of creating projects of different forms that connect to those tools. They're effectively the same thing. They're both extensions. Isaac Sim has the extension templates. Isaac Lab has the templating command line system. So I believe what Muammar has done is he has created an external project for Isaac Lab. So it's an extension that you can then manually install to connect the Python namespace and module space that you define in your extension to the broader space that's defined in the Python environment for Isaac Lab. Yeah. Is that what you were?
Exactly, yeah. That was perfect. Thank you. So yeah, I just launched I just launched the teleoperation script. So just for reference, this is the tutorial I went over. So you can find it on the Isaac Lab documentation under Overview and Teleoperation and Imitation Learning. And we will start to teleoperate this robot. And I just wanted to quickly mention that while I have used ROS2 and TF2, usually the workflow provided is with an Apple Vision Pro or a Space Mouse and other tools to teleoperate it. So you're very flexible in designing your own. So
and I'm seeing some questions about inverse kinematics, and it sounds like if you're using the Apple Vision Pro, it'd probably track your hand, and then you'd use inverse kinematics to solve for the positions of all the joints. Whereas if you got the SO101 leader, you don't need to do that. Just whatever you do with that robot, you just copy the joint positions.
The data is the same, the source is different.
Yeah, totally.
Yeah, I just want to add for this one. So in the second live stream that I had, I showed the joint state workflow with the ROS2, exactly what you meant. But the data generation script provided by Isaac Lab is running with inverse kinematics, from my understanding. So I needed to switch to TF2, which is giving me. So basically, I'm getting poses from the base to the end effector, and I wrote a script to kind of like chunk them over time into delta poses, and these delta poses are then fed into inverse kinematics to give me like a new position for the script. Yeah.
Okay.
So I'm not sure. Maybe it's possible with joint states, but I didn't manage to make it work. And so right now I'm teleoperating the real robot, and it's in Isaac Lab. So it's very similar to the joint states, but it works with inverse kinematics, like you mentioned. And in this script, I can also reset every time I don't like the position of the robot, or when I moved it and I have to move it back. So in this example, I also included a binary action joint for the gripper, which I can activate with a keyboard command to make it a bit more simple. So if I press the button, it will grab the cube. And once I put the red cube over the blue cube, it will like basically assign. Oh, sorry.
Oh, it auto resets the environment because you completed the task, right?
Exactly. Yeah, that is defined as a successful task. I kind of followed the tutorial from the Isaac Lab documentation, but I just extruded one cube and just made two to make it more simple. So yeah, that was the teleoperation script. And
one thing, just real quick, I think it makes some sense to try to add this kind of workflow into the documentation, given that a lot of developers are coming from different places, but it's really difficult if you don't know any way to, you have the follower arm, you don't have the leader arm, you have Apple Vision Pro, a Meta Quest or whatever it might be, to have these different possibilities, at least one representation of the possibilities.
Yeah, I am inclined to it. So we have walkthroughs for other parts of like RL training and stuff, but for teleoperation, imitation learning, this section of the docs really is it, unfortunately. So I agree. Yeah, we definitely need to add something like that. And I think this workflow example that you've developed, Momar, is a great target for it, for sure. I agree. Yeah.
Yeah, maybe at this point I want to also mention that I want to make a workflow, a walkthrough, and like a pipeline of everything that I did, and also the problems I faced. But I mainly wanted to target the industry and research projects, as I feel like a lot of these robots and also the training for Cosmos requires a lot of hardware, and it's normally not accessible for the average consumer.
Yeah, I agree.
I guess I will move forward. I just wanted to mention everyone can try this out themselves in simulation with a keyboard. So you can control the Franca arm with a keyboard. I think that was also shown in the last Groot Mimic live stream. So yeah. So next up, we are coming to the record demo script. So basically, this was just a teleoperation, but we want to record data. This data will then be saved into into a HDF5 file format, which is kind of similar to JSON, but I would say like way more advanced. Or it includes basically everything that you recorded, and it only includes the successful demonstrations. So I will launch this one. And feel free to go over some questions in the meanwhile. While sometimes I'm loading.
We've got a bunch. Okay, let me see. Let me start back from. Look at some of the ones Amelia has starred. Here's one regarding reinforcement learning. How can we fine-tune our reinforcement learning model using imitation learning?
This is a question that gets asked every live stream that we do. There are tons of different ways to do this. The most naive way would be to do something called behavior cloning, which is where you just use the actions as classification targets to the policy. So you treat the policy as a classifier, where the result is the action. And for very simple environments, you can get, and when I say simple, I mean like cart pole type environments. You can get some decent results with behavior cloning. But the problem with techniques like that is that you end up having slight deviations in practice that lead to states that you never learned how to classify, and so you end up with this accumulating error that results from always being slightly off from where you predict you are, and your behavior is going to drift away from your desired behavior in a process called policy drift. The policy is drifting away from the ideal behavior, and there are tons of different methods for mitigating that, from like using a GAN type a GAN type system to create a generative policy or generative policies, to making like an online critic that actively corrects the policy as it goes, to modeling the system in a more probabilistic fashion than actually calculating your deviation from the policy.
And I think it also would suffer from just the broader problem that if you do that, you're essentially overfitting to your demonstrations intentionally.
Yeah.
And whenever you have a policy is essentially a statistical model that can interpolate inside of whatever domain you've set through either your demonstrations or through your reinforcement learning randomizations.
Yeah, well, the policy just defines the mapping from state to action, right? And if you don't have a sufficiently broad distribution of data when you're fine-tuning your RL policy to behave in this specific way using imitation learning, then you're going to get a bad result. But anyway, that
totally.
question, there's tons of different ways to do it. Tons of different ways.
Real quick, just to plug Le Robot, they've made this kind of tutorial on using SO100 ARM that goes through the imitation learning to RL process. Like the entirety of the process is right there.
Yeah.
It does not include Isaac Sim and Isaac Lab from Le Robot, but there's other folks like Mormar, myself, that have created little tutorials on how to do this within the context of Isaac Lab.
Yeah.
But if you go to, I'm sorry.
I'm just saying, even though the tools may be different, the methods that are used in that are going to be
exactly. And there's explanations. I think if you pair that with the new course from NVIDIA, I forgot the name of the course, but it's about reinforcement learning. It kind of talks about the methodologies behind what you're doing in the course, but then you can use that Le Robot as a companion to that,
absolutely,
and work together.
Well, and I think that. And it also depends what your goal is, right? If your goal is to come up with new types of policies that can do extremely complex and long-running tasks, that's more on the research end, and you're going to be asking one body of questions here. If you're more industrial of mind and you want to try to do some practical things today, then I would say rather than come up with more complex reinforcement learning and learning scenarios, the ones we have right now and the tools that we have right now can help you do simple navigation tasks and simple manipulation tasks, and even with a state machine do combined kind of mobile manipulation tasks. And if you can keep your tasks simple and straightforward, then you can train for that stuff with just the existing tool set, you know?
Right.
So it really, I think it depends what you're trying to accomplish, I suppose.
Yeah. Okay, good. All right. So just for context, on future questions, let's try to go quick because we got so many. We'll never get through this.
Or Mark trying to keep us on
That's
time.
okay. Well, I want to try to hit as many questions as possible throughout the stream.
Yeah.
They're definitely, we have over 12 right now I want to hit. So anyway, but let's continue. Murmur, are you ready to proceed with yours?
Yeah, sure. So while they were answering the question, I recorded basically 10 demonstrations.
Wow.
I just want.
We didn't take that long, did we?
It's fast.
And like, I mean, as you could see, that was I think the kind of like approximately 5 minutes or something. And I just want to say that this data that I just collected is not the most clean data. I made some movements that are bad. I made some movements that are, I guess, jerky or slow, which all influences how the data is generated. But yeah, I just want to, I will skip this part. So this will just replay everything that we just saw and not really do anything with the data. But I also previously recorded 10 clean demonstrations that we could look at later if we would have the time.
Nice.
But yeah, after the teleoperation and collecting the data, we have to annotate the demonstrations. So the annotation basically puts like the sequence into distinct I'm missing the word steps, I guess. So one step, as I will show in a second, will be to pick the cube, and the second step will be to put the cube onto the blue cube. So I will say this beforehand, but the second step is done automatically, as this is the condition to make the sequence successful. So I just annotate one time, and I can start the annotation by pressing N, and I will annotate by pressing S. So I will start it, and once the cube is grabbed and slightly lifted, for example, right now, I'm pressing S to annotate it. And what you just saw was something that didn't happen in the record dataset script. For example, that he kicked away the blue cube. This happens because every time the scene resets, it is not 100% deterministic. So this can happen, and therefore you should collect more data. So the second one, I will also do the same. So it's kind of what I realized, it's kind of important that you really wait until the first task is done and not annotate while the task is present. So for example, I'm waiting after the cube has been grabbed and slightly lifted. So yeah, once I annotate all of, I guess we can go over a new question as I'm annotating these.
And they're essentially, those annotations are, you're marking kind of like, if you have like the 3-step process here, you're marking whenever it's completed the end of one of those steps. Is that right?
Exactly, yeah.
You know, it's got to the cube, it's grabbed the cube, it's, you know, yeah. And what Groot Mimic will do is it'll take each of those steps as a kind of a unit and kind of flip and reverse and mess with each of those steps, if I understand it right.
Yeah, I think we will come to that in a moment. So basically, like the scene will be randomized. I guess that's what you meant. And then the trajectories will be basically interpolated. So
right.
Yeah, these are novel. These will be novel generated data sets, which then can be used to train an imitation learning model. And yeah, we will get to that in a second.
Do we want to answer a question or two while he's annotating that data?
Sure.
Yeah, I mean, sorry, go ahead. Come on.
I was just going to answer a couple of questions since they're quick ones.
Go for it.
One from Jan. It says, what use case can you think of training a robot where one would need an Apple Vision Pro and XR Stream, meaning no high-end workstation to stream to Apple Vision Pro at hand? You don't need an Apple Vision Pro. This Apple Vision Pro just luckily has a LiDAR within it, so it allows you to capture like the hand depth and tracking much easier than you would. Having an Apple Vision Pro is great because it already has a streaming pipeline, but it's not necessary. So you could, I could see a use case when you want to have people that are doing some hand operations and you want the robot to be retargeted, retrained, and mimic the hand operations. That's why you might want to use a Vision Pro. But other than that, certainly we have leader and follower arms for the SO100. You can just use those. And similarly, if you use some of the other robots out there, I'll stop because we have not a lot of time. But you could use leader and follower arms. You can use keyboard, mouse. You can use a joystick controller. All kinds of different things. These are just common pipelines.
There's another really quick one from Garv. It says, if there is a complex task that requires a lot of steps, does that mean that you would have to annotate all of the substeps manually? Yes.
Yeah, I think from the Groot Mimic, maybe just to add quickly, from the Groot Mimic live stream, it has been mentioned that it should be kept as little as possible to not make it too difficult, I guess. But you can also set up an automated script to annotate these. So basically, you can have something like, okay, when the cube is grabbed, I will wait, like, I guess, a few milliseconds or something, and then annotate it itself. But usually, as you could see, it really only took 5 minutes to annotate 10 myself. So,
but if you did hundreds, and that's where Amazon, we have a kind of similar thing that you were working on. But if you had hundreds of thousands of these, it doesn't scale. And so what we've done is we've attached basically Gen AI to this pipeline. So you can say like doing an annotation from a vision language model. You basically slow up the procedure a little bit because generative models take longer. But then you can scale in the thousands rather than one person, annotating data.
And yeah, maybe just to show what I'm showing on the screen, or to tell what I'm showing. So basically, this is, sorry to interrupt, but I'm not sure how much time we have. So basically, we have this generate dataset script. So these are novel positions for the cubes, and basically the robot is figuring out where the cubes are and how to put it on the blue cube to generate a new data. So even from the very fast and I guess bad demonstrations that I showed before, these 10, we are able to have a success rate of 40%, which means by the time speaking, we have already generated over 40 novel synthetic motion data trajectories, which are also saved in the HDF file.
So to be clear, what's happening here is that each robot is going through trying to stack the red cube on the blue cube in a novel way. And some of them succeed and some of them don't. And the ones that succeed, you record and save for later. And the ones that don't, you discard. And what you're saying is that so far, we've of the trajectories that we've generated, about 40% of them have been successful and saved for later use.
Exactly, yeah. And yeah, perfect. Thank you for mentioning that the only successful ones will be saved. That's very important. and also,
but sometimes that's not in your data set. You want the unsuccessful attempts to some degree. Otherwise, the robot doesn't know how to recover unless you manually teach it how to recover, which is also a problem.
Sure.
But you notice steadily that the data set, the percentage of success is climbing slightly, right?
Well, or it is kind of, I saw it kind of going up and down.
Yeah, I'm not sure if that's actually training. I think it's just generating data, right?
Yeah, I don't think it's training yet.
Yeah.
And
you don't have
there have been a few questions about like longer tasks and more complex robots like humanoids. And my understanding is that Groot Mimic can do more complex robots, and it'll try to do whatever task you throw at it. However, the more complex tasks and the more complex robots would probably have lower success rates.
Well, and again, remember the big thing for Groot Mimic is that it's data generation, right? And if you're using complicated robots that move around the environment, for example, there are different constraints on that data generation than there are for a fixed base robot arm, right? And
Right.
so while it may be possible to use Cosmos and Group Mimic for all of these other more complex robots, there might be additional steps in the pipeline to ensure that they are grounded well physically.
Yeah.
And there's a whole bunch of research that we're doing internally on that subject right now, actually.
Well, and I'm seeing another question about if what Sanjuna is asking is one, and she was on just yesterday. She's great. But she asked, is one motion capture demonstration enough for Group Mimic to learn a task? Well, Group Mimic isn't learning tasks. That's Groot, and you need about 50 demonstrations to teach Groot to do something. I'd say it seems to get you started. But Groot Mimic is not a learning algorithm. What it's doing is it's taking these demonstrations that Muammar's done, and then it just uses interpolation to kind of take a stab at making a new demonstration. And sometimes they succeed and sometimes they don't.
The annotation part is necessary for identifying which of those are successful, right? Yeah.
Absolutely. Anyway, common confusion between Groot and Groot Mimic and Groot Dreams. There's these Groot products, and they're all a little different.
Yeah.
Go ahead, Muammar.
Yeah, maybe to continue. Sorry to interrupt again, but I just wanted to share quickly that like we don't have to visualize the data generation that we just saw. We can also use the headless mode, and that makes us able to use more environments. This is kind of like the key point of Isaac Lab, I think, in general, or one of the key points. And as we can see, it's generating data much quicker. And I've also used a bit like the more clean data that I recorded previously. And while we are speaking, it's generating data quite fast. I'm not sure if you can see it. I will make it a bit bigger.
And that does look like it's climbing.
Nice success. Yeah.
Am I wrong? Maybe I have a misunderstanding here. What is this the same script that you called before, or is this a different?
Yeah, it's the same script. It's just the headless mode to run more environments. So right now, it's probably running multiples at the same time, and we will see them.
Yeah, but we're surprised it has a higher success rate.
No, but it could be a law of large numbers thing, so it could be converging to
totally.
Yeah. No, I'm sorry. I think I didn't mention that before, but I use a more cleaned up version that I pre-recorded myself.
A better data set on that.
Exactly, yeah. But it's also just 10 demonstrations, but better ones.
Yeah. Cool. So, tons of great questions coming in about Group Mimic. Okay, so how are synthetic trajectories generated? I guess a foundation model is used. And I think the key here is I don't believe that Group Mimic is using a model or an AI to generate these trajectories. It's more like flipping an image in conceptually. Like it's more of like deterministic methods of it places the cubes in random locations, and then it will kind of translate and rotate those trajectories to try to make up a new trajectory that will get to that same spot. And so it's actually performing more like affine transformations on the trajectories you recorded on some statistical average of those trajectories to kind of try to guess at a trajectory that would work. And they don't all work.
Perturbations off of.
Totally.
I need to learn more.
It's really cool.
I don't have enough. I need a better understanding.
It's really some gnarly,
some
Cartesian mathematics. Whoever, I don't know who did this, but they're really good with their.
Oh, we have some wizards. We have some straight up wizards at this company.
This is some definite wizardry.
Yeah.
So it's not AI, but it's still wizardry, and that's the way I understand it. And we'll probably have a live stream with the guy who wrote it, and I'm just proven completely wrong next week. But
I want to come to that live stream too, for sure.
All right, Muammar.
Yeah, sure. I mean, it's kind of already. I've kind of already shown everything, so we generated the data. That was the whole point. But the last step, following the tutorial, so basically everything I've done, you can also look up in the tutorial. But at the last step, we can train now imitation learning models to validate if it works. So this is not Groot N1.5 yet, because we would also lack video data. But just from these joint position data, let me just call it like that, we can train an imitation learning model from the RoboMimic library, and the algorithm is called BC. So I will not show the training because it's just a script running and training, but rather show the visualization. So yeah, but by the time we talked and I renewed the script, we already generated over 200. So I think
I'm guessing that BC here is the behavior cloning algorithm, meaning that it's doing this thing that I mentioned before, where it's just treating the policy output as classification targets. But we're getting around the policy drift problem now because we've expanded the data set that we're using for behavior cloning to have a broad enough domain that it's not going to drift. It has understanding of how to recover because the domain's wide enough. But I'm not sure if that's what it is. I'm just guessing what BC might mean, if that's the case.
I think so too. I thought that there was like a link to the official page or paper, but I don't want to say something wrong. So
I need to dig into it more myself.
So so I already launched the script. So as you can see, the first 2 trials were successful. So I guess I will just restart it. I missed to show it, sorry. So while it's loading again, I just want to mention that I've trained it for 1000 epochs, and this took something like 10 to 15 minutes, I think, or maximum 30 minutes. So I could probably train on more data. And this one is done using, I think, 1000 generated datasets. So yeah, as we can see, this is now an imitation learning model that is managing to do the task. It's not perfect because I didn't use maybe enough data or didn't train it for long enough, but it's managing to do the task. So like in my eyes, it's very ready for Groot and 1.5 training. So.
And it is behavior cloning. So what's going on here? You're using the robot mimic pipeline to do the actual training part, right? So we've used Groot Mimic or Isaac Mimic, depending on our names. So that was what I was saying about before, is NVIDIA's naming conventions. That's not going to it. But you use Groot Mimic to get the data. You're using Robot Mimic to train the algorithm. And I just looked up the robot mimic algorithms that are available. And indeed, BC is the standard vanilla behavior cloning method. Mm-hmm. So it is just doing that classification targeting. But that's why the broad data set is useful and necessary. It makes it so that naive behavior cloning algorithm all of a sudden becomes useful because we have enough data set to make use of it. Yeah.
Mm-hmm. Yeah. So I guess it like on average, I think it has a success rate of something like 80 to 90%. So this one was a fail, and the robot will do very weird movements now, so I might not show it. But this basically showed that we, in this whole live stream, that just from 10 demonstrations that I recorded also in the live stream, managed to generate a lot of data. And it's kind of crazy to me how fast everything goes and how quickly you can generate these data sets. And basically the robot model is the same as in the real world. So yeah.
Absolutely amazing. And at the time it took Gus and Eric to debate one question.
Oh no.
Yeah.
he needed a time filler, so he's like, let's do all this.
Sorry.
This is amazing. This is so cool. And first of all, thank you so much for presenting the information in this type of format. Totally digestible. And I can tell by all the comments we're seeing, it's a super helpful. Okay, we got a question. I'm going to try to go from most recent to oldest, actually, so it's more relevant for right this second. So here Tom is asking, is Cosmos being used in the synthetic data process? It's not, right?
Yeah, so it's not yet. So that would be my next step. So basically, now that we have collected this HDF5 file format for these basically like all the data that we are including, we need to now, or it is recommended, I guess, to get these demonstrations into Isaac Sim to leverage Replicator or the Cosmos Writer, which is, I think, an extension to Replicator, to create basically a scenario with different types of metadata, like depth or canny edges or segmentation, I think maybe an image would be the best. So I think if I Google just quickly Groot Mimic blueprint, I think you showed it before.
Oh yeah, I have it on the screen.
Yeah.
You're looking for the blueprint page itself?
Yeah, I think I found it. I think it should be this one. Yeah.
Yeah, that's it.
So yeah, so basically what we will do, I think it's not shown here, but I guess I would have to search another page if I have 2 seconds. So.
Well, actually, while we're on that, someone also asked if this could be used for things other than robotic arms, and absolutely.
Yeah, and that's what I was commenting on before. Is that the data generation process that we're using right now is focusing on robotic arms, but especially for that third step for Cosmos data augmentation, there's no reason why it has to be a robotic arm.
Right.
I just think that with our current methods, you will find for the imitation stuff, you'll find best results with robotic arm than you will for mobile robots. But that's going to change as we develop things, right?
Okay. Well, or with like biomanipulator, like humanoid.
Yeah.
I think that it would probably work okay with biomanipulator, but you're going to have to tag more of those actions, and your success rate is going to drop. And if you could try to go with too complex of a robot, I think that success rate might drop so low that it's not really helping you much.
I actually see that FS Studios CEO Tim is actually in the wing, so I'm going to bring him up. Well, I'm not sure if he's able to talk or wants to talk, but Tim, if you want to say anything or add anything to the conversation, you're now an official panelist. So feel free to unmute yourself.
Let's see if he's there.
Okay, so we had another question here. Let me see, regarding the performance. I'll put it on the screen here. How's the sim to real performance? Have you tried it? We'd love to hear your insights.
Yeah, no, I haven't tried it yet because I would need to collect video data. But at this point, maybe I would like to, I think if I'm still sharing my screen.
Yes, you are.
Maybe give a shout out to Lightwheel AI, which they have open sourced Le Isaac, I think they called it. So it's not Le Robot, but instead Le Isaac, because they have put the SO arm into their also opened kitchen scene that they have provided for everyone.
I didn't know they did this.
Yes.
But the difference between theirs and mine is basically that they are using, as far as I know, joint states. So they cannot use Groot Mimic with this one. But basically, it's the same setup. I believe they also use the same Isaac Lab script that I've shown, if I'm not mistaken. I need to try it. Yeah, the teleop script that I've shown before. So they're also recording videos with their scene. They train it. They convert the dataset to the LeRobot dataset format, which is required if you use the Hugging Face model for Groot in 1.5. So the data conversion, and finally you can train Groot in 1.5. So yeah, just a quick shout out and thank you, because I think they will also help me in this project. So
yeah, they're amazing. They're amazing. I actually posted their LinkedIn page. I highly recommend people follow their page. Their updates are very frequent and very informative. Highly recommend them.
Well, and I just want to also jump in and say that Groot is real to sim. So Groot is trained in the real world. And so if you start with that Groot base model and then you post train with something like what Lychee's done, then it should transfer to the real world pretty well. I would think, at least.
Amazing.
Yeah.
Okay, we have lots of other questions here. Let's see how quick we can do some of these. Here's one from Robotics with Sikith. Currently, is the data only has joint angles and cube poses observation, or does it have a camera stream?
Yeah, this one doesn't have a camera stream yet because I want to put it in Isaac Sim to use Replicator to collect. So basically, Replicator is used to create synthetic data and to record it and to get all the information out of it. And using cameras in Isaac Lab is quite difficult. And as I want to use Cosmos anyway in the future, I want to directly use everything within Isaac Sim. I think that makes more sense.
Okay, great. Let me see. So we have another question here. Is there something I'm not familiar with this. So is anyone else familiar with it?
Hill SCRL.
It's human in the loop. I googled it.
Oh.
I saw that and googled it. So Hill in this case means human in the loop, and I don't think we have anything out of the box that's human in the loop reinforcement learning. However, you get to write those reinforcement learning steps yourself. And so Isaac Lab is just a Python platform, so you could just have a break in there and you do stuff and then hit some key to continue.
A great like first step to see if it can be done might be something as simple as Dagger, right?
Yeah.
Where you're getting feedback from the policy and what the policy thinks it should be doing, and you're just saying yes, no, and you annotate so many until you can tune the policy to get the behavior that you want.
Sure.
We don't have that implemented as like a out of the box pipeline, like you said, but I don't think that'd be super difficult to do. Actually, I think you did something fairly similar with your early work with the jet racer car, right? Where you had it capturing images and you were clicking on the image to direct where to turn. I mean, that's a human in the loop training pipeline that you were able to whip together for jet racer. So it's definitely
it wasn't reinforcement learning. That was just a straight up computer vision model that gave me just right or left. It was very simple, but you can. Yeah, Omniverse is such a flexible platform.
Bones are there.
Yeah.
We have a great question from Marina about what tutorial with a simple example would you recommend to start learning Groot Mimic?
I would recommend Lychee's tutorials. Honestly, they're great. They're fantastic.
I'm going to post Lychee's YouTube channel on here.
I think also you have a Notion page, don't you?
Or is
that public? Can you share that?
Yeah. So regarding the Groot Mimic, so first of all, this is my educational page. So everything is free here as well. I try to reference as much as possible also from other people. And so, for example, just the Isaac tournament that we mentioned before is hosted here with future tournaments. But coming to the project, I did not create this tutorial for Groot Mimic. But what I can recommend is, I will fill it in the future. But what I can recommend is watching the live stream that I showed before. So the office hour. Peter Du has done a really great job explaining everything. And also, thank you again, Peter, if you're seeing this for the hour that you gave me and helped me. And second of all, the tutorial here. So you can just follow everything. You can use your keyboard, everything in simulation. So I think that's a great way to start exploring kind of the whole pipeline.
Amazing. Okay, I posted those links in the chat, both for the hub and for the YouTube page. Fantastic. I agree with Gus 100%. Great resources. And obviously, a lot of resource and training materials are now coming up very quickly in searches. So also just try regular search for your favorite search engine. You'll be very surprised how recent tutorials are now showing up at the top of search engine. So I don't know if we have anyone here.
Real quick.
Yeah.
Sorry. Someone was asking if there's a way they can use Isaac Sim without, if they just want to try it out. And the answer to that is there's this thing called Brev that you can use to try out Isaac Sim. It's like it's cloud computing. And Lychee, what's so cool about Brev in your competition?
Great introduction. I guess for the tournament that is still live, people can still contribute. So basically, NVIDIA has supported the tournament with over $1,000 worth of prizes now, including the cash prize. So Brev, I think we explained it before, or you as well. So it's basically a cloud GPU that has everything set up, and it's very easy to get started. And there are basically the best GPUs that you can you dream of. So I think
web-based too, right?
Amazing. You're no longer limited by local hardware, and it's actually fairly affordable too, I'd say. And you control all of that very, very easily. So very cool. I hope people check it out. I just posted a link for Brev in the chat. But also, yeah, if you want to get free credits, you can try to win one of those prizes. That'd be pretty amazing. We have to do a follow-up stream on the winners here.
I want to see that too. Yeah,
That would be amazing.
That'd be great. Okay, I was going to say before, I don't think we have anyone here with super experience with XR, except maybe actually Bobby. Maybe you do, one of your clients. But we're getting asked here from Colin Hutchins regarding Apple Vision Pro, possible to train a robotic arm to move a piece of Kydex off a heat press.
Is it possible? So I can tell you with NDAs in place that we are currently working on a project with Apple Vision Pro and teleoperated robotics training, and be more than happy to dig a little deeper. I think actually on the sizzle reel that you showed, we showed a little bit of that work with Apple Vision Pro and robotics in that sizzle reel we sent you. But be more than happy to dive into a call with you, get you into an NDA, and we can and talk a bit more. Let's see, it's in there somewhere. I want to say it's near the end of the video.
No, it won't let me fast forward.
No, we live in a world where we can't fast forward.
StreamYard.
We're talking robotics here, and we can't fast forward.
For AWS, I actually write the AWS Apple Vision Pro tutorials, so I can also answer this question.
Oh, Kamade, amazing.
Yeah.
No worries. Yeah, if you go to AWS channel, you'll see my face all over that. But yes, you can use the Apple Vision Pro. All of its low-level libraries are accessible to you. If you have the enterprise entitlement, you can actually see what's in the camera.
There it is right there, the video.
Yeah.
Oh, I just stopped it.
Yeah, and maybe you can replay that again. But yeah, to see the camera, you need to have the enterprise entitlement for the Apple Vision Pro, which means you have to be a company or a developer working for a company. And that's the only way you can see the camera. But you get essentially a data representation of what's in the camera. So they'll say like, here's human hand, here's the points of the hand, etc. What the quaternion of the points are of the hand. So you do get a representation of the data in front of you, but for privacy reasons, they don't let you, access the camera directly unless you are a company working on an in-company, application.
Right. Yeah. Enterprise account, which we have the enterprise access to cameras. So.
Yep.
Amazing. Okay, that's so great. I'm so glad. Another great reason to have you here, Kamade. Thank you. Let me see. So Eric, I just have to say, Eric had to drop while I was playing the video. He said goodbye. He was waving. Nobody could see him, but he was waving. Thank you, Eric, for jumping on today. He has a conflict with the meeting right now. All right, we have a bunch of questions left. I'm not sure how much time people have here, because I could ask people to start posting these in the Discord chat we've set up for this live stream, and that we can answer them asynchronously over the next few days. Or if someone wants to take have a few minutes now, we can try to get a few more in.
I think what you can mention is that the study group will start in like 17 minutes, where people can ask all the questions. I will be also hosting it, so I'm happy to have the questions there.
That's amazing and very accurate. So I'm going to post the calendar here. People always ask how they can find out what is going on in terms of upcoming live streams and study groups and office hours. So our Ed event calendar is where all that stuff is listed. Including, I think we're about to post an update on tomorrow's live stream happening at this time tomorrow with a couple of the teams who participated and were in the top 30 of the Robot Hackathon. So that all those events and more, including the study group that Mormar just mentioned, that's happening in 15 minutes actually on the Omniverse Discord server. Those are on our Ed event page. So I highly recommend, if you have not joined the Omniverse Discord server, what are you waiting for? As typical, I'm going to ask the marketing team for NVIDIA to look away while I show this obscenely gross graphic. This is how you get to the NVIDIA Omniverse Discord server. I mean, people should have this tattooed on them. I actually do on my back. This is a way to interact with all the community members that are really super engaging, answering questions every day, helping each other out. Really great, positive, vibrant, supportive community. Highly recommend you go. If you go to that Discord server, you will see a live streams channel where there will be a thread on this live stream, but you will also see a study group category with the Isaac Sim and Isaac Lab channel for that study group. and that group is just getting bigger and bigger by the week with really cool developers. You can unmute your mic, turn on your webcam if you want, totally optional, or just hang out. As everybody. What are you going to cover today, Muammar? Do you have it planned already?
I think we will just tackle what we talked about. If people want to have more information, a bit more in depth. So yeah, nothing prepared except for the live stream.
Nice. Okay. So I'm gonna paste the invite for the Discord also. Let me see. All right, it's not coming up in my short list. Hold on. Give me a second here. What I will also suggest too is if you are needing official support, go to the if you're using Isaac Sim, we have the Isaac Sim support forum. If you're using Isaac Lab, you want to post on the GitHub discussions area, I think, or the issues area is the best place to go for that. Okay, so let me ask Bobby, FS Studio, what is the best way to get in touch with you guys if people really want to work with a company, they need some help, maybe they're intimidated or overwhelmed, or they don't have anyone on their team that could help from a development perspective? How would they get in touch with you guys to help?
Super easy. You can just literally drop me an email at bobby.carlton@fsstudio.com. That is honestly the easiest way. It's we get into a call. You can talk to our team. We're even offering free consulting. So if you're like a company and you're a project and you're just like, hey, we have this issue. This is what we're trying to get over this hump. We'll get in a call with you, and we'll have folks like Muammar on the call, but we'll also have some of our other devs. We'll have a project manager who's Nick Clark, who is a project manage all of our Omniverse projects. So you just get like a really thorough team to kind of sit in, listen to what's going on, and then we can kind of help say, okay, this is how we can help you. This is how we can assist you, and we'd love to partner with you. We'd love to work with you. Again, we have a lot of really great experience. We're a lot of fun to work with, hardworking, and we're not as fun as a NVIDIA live stream, but
yeah, I've hung out with you at conferences. You're a lot of fun.
Yeah, but when it comes down to business and getting solutions done for you, we definitely we dial back the goofiness a bit. Not that the NVIDIA live stream is goofy, but but we come in very professional, and we're like, okay, what can we do? And thoroughly listen. We provide options, and just drop me an email. Find us on LinkedIn, and one thing is is Muammar, he creates content for us for our LinkedIn. So if you like this type of stuff, we post all of his content on our LinkedIn page. So
amazing. Okay, that's great. And Kamada, you've actually identified a couple of quick questions, I think, that you wanted to talk about. You're muted right now.
Sorry, I was trying to see if there's a couple of questions that are easy. Yeah, this is an easy one. How does the robot know where the cube is? What sensors does it include, and which ones are best? I can answer that, but Muammar, you want to answer it?
You're muted.
We've all been there.
Yeah, I could answer it. So in Groot Mimic, so basically the position of the cube is known, but it's not a problem at all for Sim2Real because all we collect is basically these joint trajectories basically, and the video that we capture. So we can use a privileged information from the simulation to leverage that for the real world. Unlike reinforcement learning, which most of the times needs something like IMU or camera sensor data. And I think that's really powerful.
That's great. Thank you so much. And I'm actually, Amelia, thank you for setting this up. She set up a thread for today's live stream. I'm posting in the chat. Oliver, if you missed the beginning of the live stream, this was action-packed. You can watch it on our YouTube channel. Just go to the live section. You can put it in half speed, double speed. I think for this one, you probably wanted to go maybe 3/4 speed to catch all the information. But there's a thread that you can go to in the chat right now on YouTube where you can actually ask any questions specific to this live stream. I also want to make a really cool announcement that we just opened up this week, OpenUSD certification. That is pretty amazing. So you could take the learning path for OpenUSD, which is a free self-guided course on OpenUSD. And that has been available for quite some time. And now you can test yourself and get certified. It's really easy to find. I'll post the link in the chat here. We're very excited about that. So you're already seeing a stream members from the community post their certification badges up on LinkedIn. And I believe you can actually take the exam at SIGGRAPH if you'll be at SIGGRAPH, which is pretty awesome. And look at that, at the top of the page. Speaking of SIGGRAPH, there's that code I mentioned, NVID 1348 for that free Expo Pass, which also gives you access to a bunch of sessions and other stuff as well. Contact me if you miss any of this stuff afterwards. And then we also talked about Brev, which is pretty exciting and accessible. I'll also post the link in the chat here so everyone can find out how to leverage the cloud GPU for your work. Like I said, pretty affordable. I want to thank everybody for making this live stream so much fun. Murmur, let's start with you in terms of like, what do you want people to take away? You got your tournament is in progress. There's still plenty of time for people, right? Still got a few days left.
Yes, exactly. And
those bread credits and those cash prizes are up for grabs.
Yeah, exactly. So, I mean, it really, for the participation, it really doesn't take much. So all you need to do is basically in Isaac Sim, have a robot just driving, that's all. And if it looks cool or if it's like very well done, then I'm pretty sure you have a good chance of winning. So a creative idea could be made within just one day, and you can win up to like, up to $500 worth of pref credits plus 150 euros on top. So
I've seen a couple screenshots of early entrants, and it looks like it's going to be a lot of fun. It's going to be a lot of fun. Yeah.
That's super exciting. I want to thank you, Murmur. Thanks so much for putting together a tournament like this. It's really exciting. I highly recommend people follow Murmur's channel, but also check out his Discord server, which is growing every day with new users and developers. Gus, I'm sure you're on there.
I am.
That's awesome. That's great. Okay, lots of great comments. No more thanking everybody for his official account here. As I said earlier, Amelia's helping in the background. Thank you so much, Amelia, for all your help producing the live stream, putting this together. We have actually 3 this week. The last one is tomorrow with the Robot Hackathon folks. Okay, Bobby, what do you want to leave people with? What do you want people to come away with as they go home today?
Yeah, you know what? I think we touched on it earlier, and Gus brought it up. That again, looking at some of the current projects and conversations that we're having around robotics with our clients, you would be surprised at the type of companies who are talking about and asking us about robotic solutions. And it's not a robotics company. I mean, yes, they are asking, but it's not even like an automotive. We're talking financial industry. We're talking retail industries. We're just like company healthcare. These are companies that we're seeing a lot of activity in robotic solutions. And so I want people to walk away from this knowing about, the work that Mormar's doing, the work that FS Studio is doing, and that robotics in general is just this massively growing tool. And we're seeing, again, the surprise industries that you would just never think would associate robotics with stepping up, saying, hey, we're looking for a robotic solution. So, other parties, let me know how I can help you.
Awesome. That's fantastic. All right. Now we have a special treat because Kamade has a little something planned, a little something special. Nice. So Kamade, you have the floor.
Let's see if I can share my screen. And
I'll let you know when I see it.
Let's see. Yeah, I think this might be it.
Yep, I see it. Okay, here we go.
Oh, excellent. So at AWS, we're working on similar things that Lychee and others are working on, except we're trying to make sure it scales for enterprise use. So we're building out these pipelines that do some of the similar things that you see from Miramar and others. And we're also partnered with Lay Robot. So you can see there's Rob Knight. That's the Hope Jr. arm. This is Rob's creation for Lay Robot. Some of the software on it was created by me, some by Remy Cadence, and some by the gentleman behind you wearing the teleoperation gloves. It's completely open source. We're looking for contributions, including folks that want to be involved in the Isaac Lab portion of this. So we will be using Isaac Sim and Isaac Lab and Groot and whole body controllers. And we need folks that want to come help us out on the Lay Robot Discord channel.
I love it.
Yeah, a couple more things. This is This is Remy, and I'm the cameraman back there. And this is the lay robot. I'm sorry, the Hope Junior running. So that's it. It actually stands, and now we're getting it to walk.
We gotta get that into Isaac Sim.
And then I guess we can skip because I want to just keep the time going here. I'll skip a couple of these. So what we're doing is that imitation learning, reinforcement learning pipeline. We're scaling that out on AWS. The other thing we added to it, and this is kind of the coolest part, is this agentic workflow. So allowing the agentic models to take over the imitation learning pipeline. So just imagine if you haven't done something before, and I guess let me just play this one. I'm playing it with the sound off, or maybe I'll try the sound and see if you guys can hear. So I don't know if you heard that, but he said, help me prepare the instruments for surgery. And this is actually using GenAI to end a policy to pick up the appropriate forceps, or I guess those are tweezers, but those would be forceps or scissors. And then it's sending the chunking actions to this robot. This is an SO100, so it's a little bit shaky compared to the 101. But it's using the camera, is using Isaac Sim, Isaac Lab, all those kinds of things in the background.
Wow, that is so wild.
Yeah,
Wow.
and so the cool part about that is then you're now using an agent, which means you can make it do all kinds of things. And this is one of my college students. Oh, I should mention the person that developed the last one. His name is Aaron Su, along with Frank from AWS. They're solution architects on my team. And here's one of my college students who's made a dual arm. So this dual arm now is the same concept, will be running on Isaac Sim and Isaac Lab. And now he's about 40% successful in getting the trash into the trash bin with the dual arm.
Amazing.
So that's, I think I've exhausted my 2 minutes, so I'll stop there. But look for some stuff from AWS coming soon, and also look for a basic tutorial. I'm also trying to work with Mormar and others to try to put up more content. I don't put up really good looking content, but it has a lot of depth, hopefully. So hopefully using other folks, I'll be a little bit more easy to digest content. Okay, 2 minutes. That was it.
That was amazing. You're always welcome to come on and present. I think this audience loves this type of content.
I love this type of content.
Yeah. It's really fantastic. And for people, Bobby's last name is not on the screen, so I'm going to put this up on the screen. This is Bobby's last name, Carlton.
There it is.
So there, look for him on LinkedIn. Connect with him. Okay, Gus, what's your takeaway from today? What do you want people to go on?
I think that this is only the beginning. I think that the takeaway I want people to get from this is that this is only the beginning. And as these tools become more ubiquitous and more easier to use, the sky is going to become the limit for the kinds of things that you can automate with robotics through Isaac Sim and Isaac Lab and simulation tools specifically. I'm just grateful to be a part of it, and I'm excited to see what comes next. And thank you for inviting me on the stream again today. I do really appreciate being
Of course.
here.
Well, I'm so glad. Mormar had to drop. He mentioned he's headed over to the Omniverse Discord server right now. I hope all of you who are watching jump on there.
Yeah.
It'll be amazing to see a live bunch of you go there. If you go to the Discord server, just go to the community room, and that's you're going to see everybody hanging out. We're going to be talking about this topic with Mormar and other amazing people from the community. And don't forget, in 2 weeks, we have SIGGRAPH 2025 with these amazing speakers. These are going to be streamed. These presentations will be streamed online, whether you're in Vancouver or elsewhere in the world. You can watch these. You can use that QR code to find out more information. If you are going, let me know. It would be great to meet up with you while we're all in Vancouver together. And if I can help with anything along the way, absolutely let me know. Thank you so much, Gus, Tamate, Bobby, Tim, who's not here right now, but thank you, Tim, for joining in the beginning. Thank you to Mormar, of course, and Strainflow, aka Eric Bowman, fantastic hour and a half. Thank you, everyone out there in the audience watching it. You make these live streams so much fun.
Yes.
If you'd like to see more of these, definitely like this video. Please subscribe. It helps our team know that this content is important and valuable and will help us produce more. If there's content that you think we need to do because there's missing gaps in our documentation or tutorials, please let us know. If there's a partner story you'd like us to see tell, I'm very happy to research those for you and try to bring them to you live. So don't be a stranger. You can reach me anytime on LinkedIn. Best way to get there is go to edmar.net. It'll bring you right to my LinkedIn page. You can follow me, shoot me a message regarding anything Omniverse, OpenUSD, or if you just want to say hi. Thank you so much for joining us today. It's been a real pleasure. We'll see you tomorrow around the same time at 11 a.m. Pacific. We're going to welcome 2 teams who were in the top 30 of the robot competition. I got to tell you, it's going to be another awesome stream. We had a warm up earlier today with one of the teams. I can't wait for you all to meet these folks and see what they did in 2 days at this hackathon. Okay, that's it for it today. I'll see everybody tomorrow. Thanks, everybody.
Thanks, everyone.
Bye.
Bye.